This video is going to go over Module 3, Homework 1. So we made it to Test 2, radicals and radical functions. So starting off, I'll just kind of talk about radicals in general. So this is going to be the nth root of a. Nth root of a. That's how we're going to say this. Where n is going to be our root or our index. A is what's called our radicand. And that little check mark looking symbol is going to be our radical symbol. Our radical symbol. So it says simplify the following square root. Remember, these are straight from your homework, but it's going to start out as easy as it gets, and then we're going to try to go all the way down and progressively get to the hardest ones that we could find. So simplify the following square root. The square root of 25. So a lot of students look at it and say, okay, 5 and we're done. But let's look and see what's happening behind the scenes so we can take this same concept and apply it to something that's more our speed. So notice there's not a root here. There's not an index. So whenever there's no index, it's understood that it's a square root, meaning that our index is going to be 2. So our index is going to be 2. So let me write that down. If there's no index given, it is understood to be 2. There's no index given, it's understood to be 2. All right, so we have the square root. So because of the index is 2, it's telling me that we're looking for 2 of a kind. So this little 2 is telling me we are looking for 2 of a kind. If it was 3, we're looking for 3 of a kind. If it was 4, we're looking for 4 of a kind, so on and so forth. So let's break down 25 to see what's really going on behind the scenes of 25. So let's break down 25. So 25 we know is 5 times 5. However you want to break it down, it's totally fine. But 25 is 5 times 5. 5 cannot be broken down any further, so it's going to get circled. Again, 5 cannot be broken down any further, so it's going to get circled. So I broke down 25 as far as we can go. I know that the square root of 25 is the same thing as saying 5 times 5. So I can rewrite it. I could say the square root of 25, but instead of writing 25, let's write 5 times 5. This is what's called the prime factorization. I broke it down until their numbers are prime, meaning I broke it down until I can't break it down anymore. So prime factorization. All right, great. So because we know this is a little 2, it's telling me we're looking for 2 of a kind. So we have 2 25s. These are 2 of a kind. These 2 25s are going to come outside of the radical, just as 5. Nothing's left underneath the radical, so the radical is going to go away. Done. Our answer is 5. Another way to think about it while we're here is I can rewrite this as the square root of 5 times 5, which is 5 squared. So this way, the square root and the 2 exponent cancel each other out. Square root and square are opposite functions, so they cancel each other out. Just like adding and subtracting are opposite functions, they cancel each other out. Multiplying and dividing are opposite functions, they cancel each other out. Square root and square are opposite functions, so they cancel each other out. So we're just left over with 5. So again, 5 is our final answer. And our calculator can do something like this, which we're going to get something that's more our speed, but just something like this, it can do it. Notice that above the x squared button is our square root. So if I hit second, then I hit the x squared button, that'll give me my square root. So square root of 25 equals 5. Great. Let's do another one. It says to evaluate negative square root of 81. Again, there's no index, so it's understood to be square root. It's understood to be 2. Let's break down 81 until we cannot break it down anymore. So, '81 we know is 9 times 9. Now, that's already 2 of a kind, so we can stop right there. Sorry, I have stuff all over my hands. I'll turn. So, that's 2 of a kind, so I can stop right there if you want, or if you just want to keep going, breaking it down until you can't break it down anymore. So 9 is 3 times 3. Can't break it down 3 anymore, so it's going to get circled. 9 is 3 times 3. So I have that negative out front. It's going to stay out front. We have times the square root of 3 times 3 times 3 times 3. Notice in your calculator, 3 times 3 times 3 times 3 will still give us 81. So I'm not changing the problem, I'm just breaking it up. So because of this 2, we're looking for 2 of a kind. That negative 1's out front is going to stay out front. These 2 3's are going to come outside of the radical as positive 3. These 2 3's are going to come outside the radical as positive 3. Nothing's left underneath the radical, so our radical is going to go away. And we're left over with negative 1 times 3 times 3, which will give us negative 9. Same thing, if you left it as 2 of a kind up here, you'd have negative 1 times the square root of 9 times 9. That negative 1's out front, it's going to stay out front. That was already a 2 of a kind, so you didn't have to break it down anymore. And you would still get negative 9. So however you do it, you still get negative 9. All right, let's keep going. It says to evaluate the square root of 16w squared. Assume that all variables represent positive values. All right, so now we have the added thing of w squared. So if we have square root of 16, let's write down 16. If you did 4 times 4 or you did 2 times 8, it's going to give you the same answer in the end. It doesn't matter. Let's do 2 times 8. 2 is going to get circled. 8 is 2 times 4. 2 is done, meaning it cannot get broken down any further. It's going to get circled. 4 is 2 times 2. We broke down 16 until we cannot break it down anymore. So underneath the square root, we have 2 times 2 times 2 times 2 times w squared. So times w times w. So it's the square root. We're looking for 2 of a kind. These 2 2's are going to come outside the radical. These 2 2's are going to come outside the radical. These 2 w's are going to come outside the radical. Nothing's left underneath the radical, so the radical goes away. It's all being multiplied, so we have 2 times 2, which is 4w. So 4w is our final answer for that one. All right, so next we have to evaluate the cubed root. So this time we have a 3 of 27x cubed. So because of that 3, we're looking for 3 of a kind now. So because of that index of 3, now we are looking for 3 of a kind. Just like up here, if we had 2 of a kind, it came outside the radical. Now if we have 3 of a kind, it's going to come outside of the radical. So let's break down 27 just like we did previously. We know 27, let's do 3 times 9. 3 is going to get circled. 9 is 3 times 3. So we have the cubed root. Don't forget to write that little 3 as the index of 3 times 3 times 3 times x to the third power. So times x times x times x. So it's 3 of a kind. That means these 3 3's are going to come outside the radical as just 3. These 3 x's are going to come outside the radical as just x. Nothing's left underneath the radical, so the radical is going to go away. We're left over with 3 times x, which is 3x. Done. Real quick, just another way to think about it is if you wanted to write it as the cubed root of 3 times 3 times 3, which is 3 cubed, times x cubed, just like up here, the square root and the square cancel each other out. Well, here, the cubed root and the cube will cancel each other out. So the cubed root and these cubes cancel each other out. So we're just left over with our same 3x. We might use that a little bit later on, but just to kind of think about what's going on behind the scenes. So let's go to the next page. All right, so it says evaluate each quantity below or enter DNE if it is not a real number. DNE, remember, stands for does not exist. Write your answer in exact form. Do not use decimal. So if we had the square root of 196 divided by 9, I could split this up and say the square root of 196 divided by the square root of 9. Right up here, DNE means does not exist, just in case you're wondering. So the square root of 196 up top divided by the square root of 9 on the bottom. The square root of 196, you can plug this into your calculator. So square root, like we talked about earlier, was second x squared, 196. That'll give us 14. So you can just write 14, or I'm going to take one extra step just because I know it's coming up in the future. I know 196 is 14 times 14. Divided by the square root of 9. I know 9 is 3 times 3. It's the square root. We're looking for 2 of a kind. So that means these two 14s are going to come outside of the radical. Nothing's left underneath the radical, so the radical goes away. Likewise, these two 3's are going to come outside the radical. Nothing's left underneath the radical, so the radical's going to go away. We're left with 14 divided by 3. I cannot simplify 14 divided by 3. There's no number that goes into both 14 and 3. So we're done. Leave it just like this. 14 over 3. Next, I have the square root of negative 196 divided by 9. So a couple things. I have the square root of negative 1 times 196 divided by 9. Now I can split this whole thing up. Well, before we even do that, I can see that, okay, I have the square root of a negative. So we're going to talk about this in a second, but whenever you have the square root of a negative, it's going to be imaginary. So the square root of negative 1 is going to give us I, which is imaginary. So it's going to be so imaginary. So not a real number. So if we said if it's not a real number, write DNE. So our answer is going to be DNE. So for this problem, I don't have to go any further because it says enter DNE if the value is not a real number. It's not a real number because I have the square root of a negative. The square root of negative is imaginary. We're going to talk about that in a second, so don't worry about it right this second. But I know it's imaginary, so write DNE. All right, let's do the next one. Now the negative is on the outside. So negative square root of 196 divided by 9. So now that negative is on the outside, so it's the same thing as saying like negative 1 times the square root of 196 divided by 9. I can split that up just like I did on the previous problem up here. Square root of negative 196 divided by the square root of 9. So I have negative 1 times square root of 196 we said was 14. Divided by the square root of 9 we said was 3. So we have negative 14 divided by 3, and that will be our answer. So here's side by side the difference. If the negative is underneath the radical, so the square root of a negative, it's going to be imaginary, so it does not exist for this problem. And if it's negative on the outside, then it's just going to stay on the outside and give us negative 14 over 3 for our final answer. All right, let's do the next one. Evaluate the following. Now we have cubed roots. So notice up here, this was all square roots. So now we have cubed roots. So the cubed root of 343. So cubed roots, we're going to look for 3 of a kind. We're going to look for 3 of a kind. Let's break down 343. So I know 343 cannot, 2 doesn't go into 343. Let's try 3. Nope. Let's try 4. Nope. Let's try 5. Oops. Nope. Let's try 6. Nope. Let's try 7. Yes, and 7 times 49. So I can say 343 is 7 times 49. I cannot break down 7 anymore. It's only 7 times 1. So that's prime, meaning it gets circled. 49 we know is 7 times 7. And again, 7s get circled. So underneath the cubed root, 343, we really have 7 times 7 times 7. Because we're looking for 3 of a kind, these 3 7s are going to come outside the radical. Nothing's left underneath, so the radical goes away. So our final answer is just 7. So same thing for the next one. If I have negative cubed root of 27, let's break down 27. So 3 times 9, 3 is done, it gets circled. 9 is 3 times 3. 3 is done, it gets circled. So I have negative on the outside. Cubed roots, we're looking for 3 of a kind. 3 times 3 times 3. That negative's out front, it's just going to stay out front. I'm looking for 3 of a kind, so these 3 3s are going to come outside the radical. Nothing's left underneath the radical, so the radical goes away. We are left with negative 1 times 3, which is negative 3. So our final answer for this one is negative 3. Lastly, I have the cubed root of negative 125. So if I were to break down negative 125, I have negative 1 times 125. In the past, it was the square roots. We said square root was imaginary. But this time, I have cubed root. So I'm looking for 3 of a kind. Well, let's see. If I were to break down negative 1, I'm looking for 3 of a kind. If I do negative 1 times negative 1 times negative 1, negative 1 times negative 1 times negative 1, that will give me negative 1. So now I have the 3 of a kind that I'm looking for. And that can come outside the radical. So moral of the story, if you have an odd root, because of the odd nature, I'm able to break it down and break down that negative. I'll write that as a note in 1 second. Let's first break down 125. I know 125 would be 5 times 25. 5 done, it gets circled. 25 is 5 times 5. So that means underneath the cubed root, don't forget that little 3 in your radical. Notice it's literally inside like the little check mark. So the cubed root of negative 1 times negative 1 times negative 1 times 5 times 5 times 5. It's the cubed root, so we're looking for 3 of a kind. So these 3 negative 1s are going to come outside the radical. These 3 5s are going to come outside the radical. Nothing's left underneath the radical, so the radical is going to go away. We're left over with negative 1 times 5, which is negative 5. And that's our final answer. So let's write a couple little notes here. So when we have an odd root, we can break down the negative into however many negative 1s we need. So here was the cubed root, so we needed 3 of a kind. So I broke down that negative 1 into negative 1 times negative 1 times negative 1. So 3 negative 1s. Still negative 1, but now I broke it down to give me the number of negative 1s we need. And then if it's the even root, so when we have an even root, it's going to be not a real number, which in the future we're going to break down and show you. Remember that we have up here, we said we have I, which is the square root of -1. It's only the square root, and it's only -1. That's our only weird case. But we do have a weird case. So let's leave that there for now. Let's go to the next page. All right, so last page for this section. Write the correct solution to write square root of 960 as a mixed radical. Mixed radical means I could have a number out front and then I might still have a radical with numbers underneath. In the past, our radical, we took everything out of the radical, so the radical went away. But let's break down 960. However you want to do it, totally up to you. You're getting the same answer in the end. 960, let's say divided by 20, and we get 48. So 20 times, it doesn't matter how you break it down, you're getting the same answer in the end. If you did 5 times whatever, if you did 2 times whatever, however you break it down, you get the same answer in the end. So we know 20 is 2 times 10. 2's done, it gets circled. 10 is 2 times 5. 2's done, 5's done. 48, let's do, I don't know, 6 and 8. 6 is 2 times 3. 2's done, it gets circled. 3's done, it gets circled. 8 is 2 and 4. 2's done, it gets circled. 4 is 2 times 2. So I broke it down until you can't break it down anymore. Again, however you break it down, you're going to get the same answer in the end. So we have the square root, so that means we're looking for 2 of a kind. I have 1, 5, or let's write down our 2. 1, 2, 3, 4, 5, 6 2's. 1, 2, 3, 4, 5, 6. So 1, 2, 3, 4, 5, 6 2's. We have a 3, and we have a 5. So 2 times 2 times 2 times 2 times 2 times 2 times 3 times 5 is still 960. We just split it up. Again, however you split it up, you're going to get the same breakdown right here in the end. It's the square root, so we're looking for 2 of a kind. So these 2 2's are going to come outside the radical. These 2 2's are going to come outside the radical. These 2 2's are going to come outside the radical. And then I have that one poor little lonely 3 and the one poor little lonely 5. There's not a pair to come out with it, so that means they're left underneath the radical. So outside the radical, we have 2 times 2 times 2, which is 8. Underneath the square root, we have 3 times 5, which is 15. So our final answer is 8 square roots of 15. Let's do another one. So simplify the radical expression. The square root of 4, g to the 6th, d to the 4th, b to the 8th. Assume that all variables represent positive values. All right, couple different ways here. I'm going to do it both ways to kind of show you whatever works best for you, you do you. So we know 4 is 2 times 2. So let's go over here to the square root of 4, which is 2 times 2. So 2 times 2 times g to the 6th. Let's write out 1, 2, 3, 4, 5, 6 g's. D to the 4th, so 1, 2, 3, 4 d's, times b to the 8th. So 1, 2, 3, 4, 5, 6, 7, 8 b's. I just wrote everything out. I like this way because it's really tangible. I mean, like you can really see what's going on behind the scenes. It is the square root, so we're looking for 2 of a kind. So let's take out our pairs. Let's take out our 2 of a kinds. So these 2 2's are going to come outside the radical as just 2. These 2 g's are going to come outside the radical as just g. These 2 g's are going to come out as g. These 2 g's are going to come out as g. These 2 d's are going to come outside the radical. These 2 d's are going to come outside the radical. These 2 b's are going to come outside the radical. These 2 b's are going to come outside the radical. These 2 b's are going to come outside the radical. And these 2 b's are going to come outside the radical. Nothing's left underneath the radical. Everything came out as a pair, so the radical's going to go away. So we are left over with 2 g times g times g, which is g to the 3rd power. D times d, which is d squared. B times b times b times b, which is b to the 4th power. And that's our final answer. So math is all about making things, using patterns, making things less, I guess you could say easier, but less complex. To me, I think this is easier, just writing it all out. But sometimes, what if you had b to the 20th? You'd write out 20 b's, and then you might mess up, in your counting or something along the way. So to kind of make things faster, make things more efficient, we have another option. Whatever way you like better, you do you. So the square root, underneath the square root, we have 2 times 2, which is 4, g to the 6th times d to the 4th times b to the 8th. Notice we're taking out groups of 2. So these two 2's are going to come out. Instead of writing out 6 g's, I know I'm going to take out groups of 2. So I can say, okay, g groups of 2, I can say 6 divided by 2. That would give me 3 groups of 2. So g to the 3rd power. I can divide by my index of 2. Likewise, if we have 4 d's, I'm taking out groups of 2. How many groups is that? Well, if we have d, 4 divided by 2 would give us 2. 2 groups of 2 came outside the radical. Lastly, b to the 8th power. I'm taking out groups of 2, so b, I have 8, and I'm taking out groups of 2, so I'm dividing by 2. So we have b to the 4th power. Same answer as you can see over here. Different way to do it. Oops. So you do you. Let's look at the next one. Simplify the following square root. Assume that all variables represent positive real numbers. This time I have the 4th root, so I'm taking out 4 of a kind. 4th root of 256, y to the 16th, w to the 20th. Let's break down 256. However you want to break it down, up to you. 256 divided by 2. Yes, I don't know. So 2 and 128. 2's going to get circled. 128 is 2 times 64. 2's going to get circled. 64 is 2 and 32. 32 is 2 and 16. Oops. Sixteen is 2 times 8. 8 is 2 times 4. 4 is 2 times 2. All right. So underneath the 4th power, we have 1, 2, 3, 4, 5, 6, 7, 8 2's. And instead of writing out 16 y's, let's put y to the 16th, and we can use our little exponent thing over here. W to 20th power. We can use this little shortcut. So it's 4th root. We're taking out 4 of a kind. So 1, 2, 3, 4. These 4 2's are going to come outside the radical as just 2. These 4 2's are going to come outside the radical just as 2. We have 16 y's. We're taking out groups of 4. So dividing by 4. We have 20 w's. We're taking out groups of 4. So dividing that by 4. So we're left over with 2 times 2, which is 4. Y to the 16th divided by 4, which is 4. W to the 20 divided by 4, which is 5. So we're left over with 4. Y to the 4th, W to the 5th. Real quick, likewise, if you did 4th root, I had 8 2's, so 2 to the 8th power, times y to the 16th times w to the 20th. So taking out, I had 8 2's, I'm taking out groups of 4. 8 divided by 4 will leave us with 2 squared. 2 squared is 4. Y to the 16th, I'm taking out groups of 4. 16 divided by 4 would give me y to the 4th. W to the 20th, taking out groups of 4, so 20 divided by 4 would leave us with 20 to the, W to the 5th power. So you get the same answer either way, but if you like to write out all the 2's or write it exponential form, either way is totally fine. All right, let's keep going. Last 2. Try to evaluate negative 5th root of negative 3,125 without using a calculator. Write D and E if it's not real. Well, right here I see that we have an odd root. Let me write a little note real quick here about we're going to divide by our index. So let me write that as a quick little note, sorry. Divide our exponent by our index. It was the fourth root, so it's going to be divided by 4. All right, so going back, I have negative fifth root of negative 3,125. Right now I know it's an odd root, so I don't have to break down that negative. So odd root. So we're going to break down the negative. Under the radical. All right, so this negative's out front. It's going to stay out front. We have the fifth root of negative 1 times 3,125. That way the negative is separate. Let's break down that negative 1. We know it's negative 1. Fifth root, so negative 1 5 times. 1, 2, 3, 4, 5. Because negative 1 times negative 1 times negative 1 times negative 1 times negative 1 is still negative 1. So now we have 3,125. Let's break that down. So divided by 5 is 625. So 5 times 625. 5 doesn't get circled. 625 is 5 times 125. 5 doesn't get circled. 125 is 5 times 25. 5 doesn't get circled. 25 is 5 times 5. And then here's those 5 of a kind that we're looking for our negative. So that negative's out front, it's going to stay out front. So I have negative 1 times the fifth root. So this negative is out front. It's going to stay out front. I have 5 negative 1s underneath the radical. Negative 1 times negative 1 times negative 1 times negative 1 times negative 1. And I have 1, 2, 3, 4, 5 5s underneath the radical. So that negative 1's out front. It's going to stay out front. It's 5 of a kind, so these 5 negative 1s are going to come outside the radical. And then these 5 5s are going to also come outside the radical. Nothing's left underneath the radical, so the radical is going to go away. We're left with negative 1 times 5, which is positive 5. Negative 1 times negative 1 is positive 1, and then times our 5. All right, last question. So the formula V equals the square root of 2.3R models the maximum safe speed V in miles per hour at which a car can travel on a curved road with a radius of curvature R in feet. A highway crew measures the radius of a curvature at an exit ramp on a highway as 410 feet. What is the maximum safe speed? For this problem, round your answer down to the nearest whole number. Think about why this type of rounding would be appropriate for this scenario. All right, so it gave us this formula. So V equals the square root of 2.3R, where R is the radius. They told me that the radius, or R, is 410 feet, so I can plug in that 410. So square root of 2.3 times R, which is 410. So I have the square root, remember, second x squared. Second x squared would give me the square root, 2.3 times 410. And that would give me 30.708, blah, blah, blah. All right, it says round down to the nearest whole number. So I have 30.7. Even though it's 0.7, we're going to round and say it's going to go down to 30. And this is our speed, because V is our maximum safe speed. So this maximum safe speed is that V that we're looking for. And it's in miles per hour. So that's our answer. So 30 miles per hour. Think about why you might do this type of rounding. So if you have 30.7, blah, 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 you're not going to say on your speed limit sign 30.7. But if your maximum speed is 30, I can't go over to 31 because that would be too fast. So that means I have to bring it back down to the nearest whole number, which would be 30. So 30 miles per hour. Whenever it's rerounding like this, it'll tell you in the problem, so don't worry. So that is all of Module 3 Homework 1 notes. I hope that you enjoyed the video. You can now complete your Module 3 Homework 1 homework assignment. If you have any questions, please let me or one of the tutors know. If not, have a great rest of your day.